Prime factorization is very important for just working with natural numbers. Prime factors of 84 are 2, 3, and 7. 84 can be rewritten as 2 times 2 times 3 times 7. This is by the fundamental theorem of arithmetic. Every natural number has a prime factorization that's unique. So 2 squared times 3 times 7 is the unique way of writing 84. Now, polynomials can be factored, which is similar to prime factorization and very much helpful to work with, just like prime factorization is helpful to work with. So this polynomial here, this can be actually factored down into three kind of distinct factors: 2x plus 3, y minus 1, and 3z plus 1. Actually multiply this thing out and prove to yourself that this is the same thing as this. This is a nicer form though, because it's more compact and actually is more easier to work with in a lot of ways. Now, there's a few steps that we can try to factor a polynomial. The first one you should always do is factor out the greatest common factor, or the GCF. The reason why we do this is because when you take out the greatest common factor, typically the numbers and the powers on the variable become smaller, therefore easier to work with. So for this first one here, I can look at all these things. I can look at the numbers and say 12, 20, 4, 8, 16. What's the greatest thing that can divide evenly into all 5 of these numbers? And the biggest thing that can divide evenly is 4. 4 can go into all of them. Anything larger than that will actually make this one a fraction, and we don't want that. So we're going to take out a 4 and then look at the powers of t. So we have t to the 6, t to the 5, t4, t3, t2. All of them have at least 2 t's in there. So I can take out a t squared. So that's going to give me, I'm going to divide 4t squared out of this. 12 divided by 4 is 3. And t to the 6 divided by t squared, that's a division of like bases. So we're going to subtract the exponents. 6 minus 2 is 4. Negative 20 divided by 4 is negative 5. T to the 5th divided by t squared, 5 minus 2 is 3. 4 divided by 4 is 1. T to the 4th divided by t squared is just t squared. Then we get 2t. And finally, negative 4. No variable there. Actually, t squared divided by t squared is 2 minus 2 is 0. So t to the 0 is just 1. It's been taken out completely. And we can look back at this factored polynomial here. And I can say, well, there's no greatest common factor, 3, 5, 1, 2, and 4. There's no common thing there. And there's not a t in all of these terms, right? This one doesn't have a t there. So I have taken out the greatest common factor. The GCF of this polynomial is 4t squared. Okay, from the next one, this one, it's a little bit strange, but actually the greatest common factor is easy to find. It's 2d plus 3. Both terms have that in there. So I'm going to take out this 2d plus 3. I'm going to take out the smallest power of it. In this case, the smallest power is negative 1 over 6. So I'm going to take out 2d plus 3 to the negative 1/6 power. And that's going to give me, well, here we have 6d for sure that hasn't been touched. And then now we have 2d plus 3 to the 5/2. Sorry, 5/6 is being divided by what I took out of it, 2d plus 3 to the negative 1/6. This is a division of like bases. The base is 2d plus 3. I'm going to subtract the exponents. So we're going to have 5/6 minus negative 1/6. Those negatives cancel, and we get 6/6, or just 1. So this just becomes 2d plus 3. Okay, I take out a 2d plus 3 to the negative 1/6. So this term has been taken out of there. And all that's left here is just 5. And you can see, well, I could distribute this 6d in there if I wanted to. 12d squared plus 18d plus 5. And there's no common factor there to remove. So this is simplified. Give it a try in number 1. All right, if we have a binomial, then we can look through and use one of the following if possible. So a sum of squares, if you can write the binomial as some number squared plus some other number squared, this is actually what's called prime. And in a prime factorization, if you have a prime number, you cannot factor it any further because it is itself prime. Now, a squared plus b squared is prime in that it cannot be reduced any further unless we were to use complex numbers, which we're not interested in here. So it's prime over the real numbers. So a squared plus b squared is the best you can do. You just leave it there. Now, a difference of squares, on the other hand, this can be factored down into a plus b, a minus b. And what I recommend you do is distribute this thing out. Actually do the, a times a times negative b, b times a, b times negative b, and show yourself that this does multiply out into a squared minus b squared. If it's the sum of 2 cubes, then this thing can factor down into a plus b, then a squared minus ab plus b squared. A plus b is a nice factor there. A squared minus ab plus b squared. This is actually prime. This cannot factor any further unless we use complex numbers. Then a difference of 2 cubes. If you can write it this way, this actually factors down into a minus b, a squared plus ab plus b squared. So these are very similar to the sum and difference of two cubes. All that's been flipped here is this positive and negative sign. All right, let's give it a try. So for this first one, I see here that there's actually a greatest common factor I can take out. In this case, I believe I can take out 32 out of 108. Let me test it on my calculator. 108 divided by 32. Nope, I need to take out something smaller. 16 doesn't work. 8 doesn't work. But 4 does. So I'm going to take out a 4. That's going to leave me with 27 minus 4 out of 32 is 8. Okay, and now I have a binomial on the inside here. And the question is, can I make it into one of these 4 forms? If it's a sum of squares, then I know I'm done. Sum of cubes, or sorry, difference of cubes, I can break it down like this. And sum of difference of cubes, I can do this. What tells me that this is a cube is, of course, the power on w. So I know I'm going to look for one of these 2 things, a cubed plus b cubed, a cubed minus b cubed. And I know specifically I'm going to look for a difference of cubes because we have a subtraction. So let's look for a difference of cubes. Now all we have to do is write this in a cubed minus b cubed form. So 27 is the same thing as 3 cubed. 8 is the same thing as 2 cubed. So I can write this as 2 cubed times w cubed. And I can rewrite both of these in this form. 3 cubed minus 2w cubed. The 2w becomes like this because of a rule of exponents. If you can distribute in a power over multiplication, you can undistribute or factor it out the same way. So here we can see that a equals 3 and b equals 2w. And so I can use this, this form here and immediately factor it. The 4 is still out in front. A minus b is 3 minus 2w. a squared, that's going to be 3 squared, which is 9, plus a times b. A is 3, b is 2w, so we're going to get 6w. Then plus b squared. B squared is 2w. Squaring that, I get 4w squared. And I am done. This is the factored form. All right, for the next one, I have x squared, and then I'm looking here for squares. 16 is the same thing as 4 squared. So I have x squared plus 4 squared. So a is x, b equals 4. However, this is a sum of 2 squares. It's prime. So I cannot factor this down. This is by itself the best that I can do. Okay, for the next one, I see I can take out an m squared from both terms. And here, 625, this is actually the same thing as 25 squared. And m to the 4th power, I'm going to write like this, 25 squared. M to the 4th power is the same thing as m squared squared. So this is actually a difference of 2 squares. And a difference of 2 squares says that we're going to take the plus version of a and b and the minus version of a and b. So the plus version of a and b, a is just 25, b is m squared. This m squared is also out in front. Plus version is 25 plus m squared. The minus version is 25 minus m squared. Once again, a was 25, b was m squared because we have the square on the outside of those. But I can go further here. 25 is 5 squared. And now you can see that I have a sum of 2 squares, 5 squared and m squared. This is prime. I can't factor this down any further. And here I have 5 squared minus m squared, another difference of 2 squares. Here a is 5 and b is m. So I can factor it down one step further. This one stays the same. I can't factor that. And then I get a plus b, a minus b. And that is completely factored. The 25 plus m squared is prime, so I can't remove that down any further. And this is the key thing I wanted to show you with this last problem, is that you sometimes have to keep asking the question, can I factor this down further? And if you can, you need to keep going. Okay, give it a try in number 2. Now, if we have a trinomial, we can either use the AC method or guess and check if you know how to do that. I'm going to show you the AC method because it gives you a process to follow, and it works pretty well. So first off, you always want to take out the greatest common factor. In this case, I can take out an s squared, and from all the numbers, I believe I can take out 4. Let's try 68 divided by 4. Yes. So I'm going to take out a 4s squared. That's going to leave me with 6s squared minus 17s plus 5. This thing in parentheses is a trinomial, and so I know I can do the AC method on this, or at least I can try it. And this is how the AC method goes. I'm going to create this little cross diagram here. And the AC method is called that way because we're going to look at it like this. ax squared plus bx plus c. A is going to be the number in front of the squared term. The variable doesn't really matter here. It can be x, it can be y. In this case, it's s. It's just a variable. But a, b, and c do matter. They're the numbers in front of the portions. So in front of the squared term, a is 6, b is negative 17, and c is 5. So the AC method is a times c, or AC. 6 times 5 is 30. And on bottom goes b. b is negative 17. Now what we're looking for is two numbers that goes here and here that multiply to give the top, give 30. 8 times c was multiplied, so you're going to multiply to give the top, and add to give the bottom. Now, if you're not sure, hopefully you can find it right away, but if you're not sure, you can always look at factors of 30. So 30 is 1 times 30, 2 times 15, 3 times 10. Not 4 doesn't go in there evenly. 5 times 6, and then 6 times 5. And that's the stopping point there because we've just flipped the 2, and that there's really no need to continue. The next one will be 10 times 3, 15 times 2, and so on. And now what we're going to do is we're going to try and add to get the bottom. We're looking for 17, for negative 17 specifically. 1 plus 30 is 31. 2 plus 15 is 17. And this is the number we're looking for, but we want it to be negative. I can do that by making both of them change the sign. In this case, both of them change to negative. Negative 2 times negative 15 is still positive 30. Negative 2 plus negative 15, however, is negative 17. And that's exactly what I wanted. So I have negative 2 and negative 15. Okay, with those two special numbers found, now we can continue the AC method. So I'm going to write this 4s squared still, that hasn't been changed. And now I'm going to write this first term, 6s squared. Then I'm going to write negative 2. And I'm going to use the middle variable, which is s. Then I'm going to write negative 15. Again, the middle variable s. And then bring down the positive 5. And so essentially all I've done is I've brought down this first term, broken up this middle term into two special numbers, and then brought down this next term. I have not changed anything. I've just rewritten it in a form that's actually easier to work with. Okay, now, let me write this 4s squared off to the side here. Now I'm going to do what's called factoring by grouping. I'm going to look at the first two terms and ask, what's the greatest common factor? What can I take out? So the greatest common factor out of the first two terms is 2s. That leaves me with 3s minus 1. I divide it out of 2s, so I get negative 2s divided by 2s is just negative 1. Now I look at the next two terms, and I ask the same question. What's the greatest common factor? It's going to be 5. Because this is a negative, if it were a plus, I'd put a plus here. In this case, it's a minus. I'm going to put a minus here. I'm going to take out a negative 5. That leaves me with, here, negative 15 divided by negative 5 is going to be 3s. Positive 5 divided by negative 5 is negative 1. And you'll notice 3s minus 1, 3s minus 1. If you've gotten the same thing, you've done it correctly. Okay, 3s minus 1 is actually a greatest common factor. I can take out of this term and this term. Taking that out, I get 4s squared. The thing that's the same, 3s minus 1. And that leaves me with, I've taken the 3s minus 1 out of both of these, so I'm left with 2s minus 5. And this is the factored form of this initial polynomial. You can prove it to yourself by multiplying it all out. You're going to see that we're going to get back to the 24s to the 4th minus 68s cubed plus 20s squared. Now, when you're doing the AC method and you can't find any two numbers, you've checked through everything, you can't find any two numbers, then typically you're going to say it's prime. There are still probably ways of factoring it that you could be factored over the real numbers, but normally when that happens, that means it cannot factor over real numbers only. You need to have complex numbers to do it. Okay, the next one, I'm going to rewrite this in standard form. We want to have standard form here for the AC method, and then I can take out a greatest common factor of 2. Okay, this is the trinomial. Let's go ahead and do it. A is 1 here, right? 1's in front of that one. B is 3, and C is negative 40. So A times C on top, A times C. 1 times negative 40 is negative 40. B on bottom, B is positive 3, A, B, C. So two numbers that multiply to give negative 40 and add to give positive 3. So negative 40 is 1 times negative 40, 2 times negative 20, 3 can't go in there, 4 can, 4 times negative 10, 5 times negative 8, 6 can't go in there, 7 can't, so now we're going to have 8 times negative 5. Here we have negative 39 when we're adding, going across, negative 18, negative 6, negative 3, that's almost what we want. If we just change the signs, negative, positive, that's actually what this next one was, that will change the sign here. Negative 5 plus 8 is positive 3. Negative 5 times 8 is negative 40. So that all works out. Always double check your work. Make sure it fits the exact thing, because it's easy to make an error here since there's so many steps. Okay, now I don't actually need to do the full AC method, but I'm going to show you it anyway. There is actually a shortcut for this one. I'll show you that here at the end, just to give you an idea what the full AC method is again. I'm going to bring down the first term. I'm just going to write y squared, not 1y squared. Then minus 5, central variable y, plus 8, again the central variable y. Then bring down the next term, minus 40. So once again, I just broke up the 3y into two things that are very, very special for our polynomial. Okay, from the first two terms, I can take out a y. Right in blue here. That leaves me with y minus 5. From the next two terms, I can take out an 8. This is a positive, so I'm going to take out a positive 8. That leaves me with y minus 5. And you can see I have the same thing here. So I can take out the y minus 5. That leaves me with y plus 8. And I'm done. Now, this actually had a shortcut method because a equaled 1. When a equals 1, then I can, once I find these two numbers here, negative 5 and positive 8, I can immediately factor this thing. I don't have to do the second half, the factoring by grouping that I've shown here. Because when a equals 1, I can write the variable, which is y, minus 5, y minus 5, y minus 5, y plus 8, y plus 8. It actually ends up being just put the variable and then minus 5 or whatever number it is there, and then the variable y plus 8 or whatever number is there. That's the nice thing about when you have a equal to 1. You can skip a lot of this work and go directly to the answer. It becomes much faster that way. Okay, give it a try in number 3. Now, if we have a polynomial with 4 terms, we can try factoring by grouping. That was the second half of the AC method, so we're going to do the same kind of thing here. Look at the first two terms, ask what can I take out of there? I can take out an 8m cubed. That's going to leave me with 2m. And here it's going to give me 3. The m cubed got taken out, and we just have n. Okay, from the next two terms, I can take out, again, this is a negative. I'm going to take out a negative 2m minus 3n. There's no common number, no common variable. I can always, however, take out a 1. So I'm going to take out a negative 1. Again, that's because the first sign there was negative. So I'm going to take out a negative 1. Negative 2m divided by negative 1 is 2m. Negative 3n divided by negative 1 is positive 3n. And you can see I have the same thing. I can take out the 2m plus 3n. And I get remaining 8m cubed minus 1. Now, this case, actually, I can continue because 8m cubed minus 1 is actually the same thing as 2m cubed minus 1 cubed. It's a difference of 2 cubes, which means I can factor that down into, just go back and look at the formula that I showed you. It's going to be A is 2m, B is 1, A minus B, then A squared, it's going to be 4m squared, plus A times B, 1 times 2m, plus B squared. B is 1, so 1 times 1 is 1. And this is completely factored. Okay, try it out in number 4. Now, what we want are linear factors or polynomials with degree 1. These are what are linear factors. We want those specifically, but if we have prime factors as an end result, then that's okay too. So linear factors are like x plus 3, y minus 1, anything, s minus 15.6. You can see that the power on the variable is 1 and only 1. Now, prime factors, we can factor them further. They do require some more advanced techniques, but we're not going to be looking at those. We only want these linear factors or prime factors for now. And to factor any polynomial in general, all you're going to do is run through that list. You're going to take out the greatest common factor, ask, is it a binomial? Is it a trinomial? Do I need to do factoring by grouping? And then do that, and then always ask, can I factor this further? So here we have x to the 4th minus 3x squared minus 4. So for this one, this is actually a trinomial. I can try out the AC method on this. Even though it's not in the standard form, the ax squared plus bx plus c, we can try it out still. So in this case, a is 1, b is negative 3, and c is negative 4. So the AC method is going to be a times c, 1 times negative 4, and b on the bottom is just negative 3. Two numbers that multiply to give negative 4, add to give negative 3, that has to be negative 4 and positive 1. You can double check that. Okay, and now we're going to do the AC method. So we're going to write, actually this is a equal to 1, so I can immediately factor this thing using the shortcut. This is the same thing as the variable here is not x to the 4th, but x squared. It's always the central variable. X squared minus 4, x squared plus 1. If you don't believe me, multiply this thing out. Actually distribute it, and you're going to see it's going to simplify down into this statement. Double check the work. You can. At this point, you need to ask the question, can I factor this down further? The answer is yes. This is a difference of 2 squares. This one's actually a sum of 2 squares, so this can't factor any further. But this one can. So x squared minus 4 is the same thing as x squared minus 2 squared. So here a is x, b is 2. Don't let the a and b that I'm referencing here for the binomials and this thing confuse you. A and b are just dummy variables. You can use them however you need to. This thing factors down into a minus b, a plus b. where a and b are x and 2. Okay, that means that this thing factors down into x minus 2, x plus 2, and then x squared plus 1. X squared plus 1 is prime. Once again, x minus 2, these are linear factors. This one's a prime factor, so we can't factor any further. This is our final answer. That's what you're looking for when you're going to factor anything in general. All right, give it a try in number 5.